Okay, so now in this video we want to talk about capacitors. Capacitors in series and capacitors in parallel. So as you can remember, of course, it was not many videos ago. So basically you can connect resistors in series and parallel. So for example, suppose that you have some resistor over here, you can connect it to some other resistor, R1 and R2, and basically if I call this resistance, for example, R of T, if I call this resistance R of T, then R of T is going to be equal to R1 plus R2, meaning that when you connect two resistors in series, the resistance of this resistor R1 is just simply added to the resistance of the resistor R2. And if you have basically two resistors, for example R1 and R2, and connect them in parallel, then what happens is that if I call this resistance, for example, this resistance, if I call it R of T, then this resistance is going to be calculated by so suppose this is R1 and this is R2, right? So then this is going to be 1 over R of T is going to be equal to 1 over R1 plus 1 over R2. So you take the reciprocal of meaning that the reciprocal of that R of T is equal to the sum of the reciprocals of these two resistors. So that's basically what happens in the case of a resistor, and then you can of course add these together. For example, R1, R2, R1 plus R2, and this is 1 over R of T. So then based on this, R of T would be the reciprocal of this, which is R1, R2 over R1 plus R2. Okay, so that is basically what happens in resistors. Now, in the case of capacitors, you will have the exact opposite situation, the exact opposite of this situation, meaning that if you connect capacitors in parallel, if you connect two capacitors in parallel, something like this, connect these two capacitors in parallel, and then for example suppose that this is C1, this is C2, then basically if I call this C of T, the total, basically the equivalent capacitance or the total capacitance, this is going to be calculated by basically C of T is equal to C1 plus C2. Is going to be C1 plus C2. And on the other hand, and of course you can see that over here positive is connected to positive and negative is connected to negative. On the other hand, if you have these two capacitors, for example this capacitor C1 and this capacitor, for example C2, C1 and C2, connected in series, and if I take this, if I take this as basically C of T, then to calculate this C of T, basically 1 over C of T is going to be equal to 1 over C1 plus 1 over C2. So the reciprocal of this value C of T is the sum of the reciprocals of the value of the value of capacitance related to capacitor to C1 and C2. So that's the exact opposite of what happens in the case of basically two resistors. So now let's do a couple of these and see basically what happens. Do some calculation with this. Let's see what happens here. Oh, I need to. Okay, so now suppose that you have, for example, a capacitor C1. You have a capacitor C1 connected in parallel with another capacitor C2. So what's going to happen is that basically take this as C1, take this as C2. This is, for example, 1 microfarad, and this is 2 microfarad. So then basically C of t is going to be C1 plus C2, because they are connected in parallel. You just add them together, which is equal to 1 microfarad plus 2 microfarad is equal to 3 microfarad. And if you have, for example, another network of capacitors, for example, you have these two capacitors here, all parallel, and this is going to be your basically C of t. This is going to be your C of t. So then suppose that this is C1, C2, and C3. The value of this one is equal to 1 microfarad. The value of this is 1 microfarad. The value of this is 2 microfarad. The value of this is 3 microfarad. Then C of t is going to be equal to C1 plus C2 plus C3, which is equal to 1 microfarad plus 2 microfarad plus 3 microfarad, which is equal to basically 6 microfarad, So in simple in other, basically we can simply say that the total capacitance of these three parallel basically capacitors is just simply found by simple addition of the capacitor values basically. Now if you have, for example, two capacitors connected in parallel, so suppose that you have, for example, one capacitor over here, call it, for example, C1 and C2. The first one is 1 microfarad, the second one is 2 microfarad, and you want to find the total capacitance here, from here all the way up to here. So the formula for this is basically 1 over C of t is equal to 1 over C1 plus 1 over C2. So, and of course if you had an n number of capacitors, then basically 1 over C of t would be 1 over C1 plus 1 over C2 plus 1 over C3 plus all the way up to 1 over C of n. So now then the total capacitance here, for example, would be 1 over C of t would be equal to 1 over 1 plus 1 over 2, and of course the unit is in microfarads, not in farads, because both of them are in microfarads. So that's basically 3/2 microfarads. 3/2 microfarads. Now this is 1 over C of t. So that means that C of t itself is the reciprocal of this, which is 2/3 microfarads. Okay. And basically for two capacitors, you can of course derive a simpler formula, meaning that, for example, if 1 over C of t is equal to 1 over C1 plus 1 over C2, then you can basically say that 1 over C of t is equal to C1 times C2, and then here you will get C1 plus C2, and then here you will get basically then C of t is equal to C1 C2 over C1 plus C2. This value is the total capacitance of basically of C1 and C2 connected in parallel, in series, connected in series. Okay, so connected in series. Now let's do a couple of examples here to basically let's do a couple of examples here. Now suppose that, for example, you have a couple of capacitors in series. All of these examples that I'm about to tell you about are in series. So now suppose that, for example, you have C1 is equal to 10 microfarad and C2 is equal to, for example, 5 microfarad. So if C1 is 10 and C2 is equal to 5 microfarad, then and they are connected in series, we said that C of t is equal to C1 plus C1 times is equal to C1 times C2 over C1 plus C2. Okay, so that's equal to, basically, if the units are all in microfarads, then you don't have to convert them. But if one of the units were in farad and the other one was in, for example, picofarad, then you would have to basically convert both of them to the same units, basically. So now C of t is equal to C1 times C2, which is 10 times 5 over 10 plus 5, which is equal to 50 over 15, which is divided by 5, 3 divided by 5, 10, that's 10/3 microfarad. 10/3 microfarad, which is something about 3.3 microfarad. Now if you had, for example, two capacitors, for example, 220 microfarad, suppose that you have C1 is equal to 220 microfarad, and you have C2 as 330 microfarad, and you have C3 as 470 microfarad, then and these capacitors are all connected in series, then you would have 1 over C of t is equal to 1 over C1 plus 1 over C2 plus 1 over C3. So 1 over C of t is equal to 1 over 220 plus 1 over 330 plus 1 over 470, all in microfarads. So then you need to somehow find the LCM of all of these numbers. Now to find the LCM, you can always use a calculator, but we can have a little bit of fun with mathematics as well here. So let me show you, for example, how you could find the LCM of these three numbers using, for example, factorization. Okay, so now basically, in order to take the LCM, or the least common multiple of these numbers, what you can do is that well, you can write this as, for example, 220. For example, 220 is basically 2 times 110. That is 2 times basically 55. And 55 is 5 times 11, for example. So you can say that 220 is the same thing as 2 raised to the power 2 times 5 times 11. And of course you can see that basically these, for example, 2 is a prime number, meaning that 2, the only way that you can write 2 is 1 times 2. But for example, some number like, for example, 6, you can still write it in simpler forms or in simpler numbers, or in other words, you can write it in prime numbers, meaning that you can write it as 2 times 3, for example. But 2, the only way that you can write 2 is 1 times 2. Or the only way that you can write 3 is 1 times 3, for example. So this is a composite number, this is a prime number. So what you need to do over here is just prime factorize your numbers. And for example, 330 is 2 times, for example, 150 plus 15 is 165. And that is 5 times, for example, 165 divided by 5 is equal to, for example, 3 times 5 is equal to 15, 15, 33. Right? So 33, and 33 is 3 times 11. 3 times 11. So that means that 330 is equal to basically 2 times 5 times 3 times 11. Times 11. 470 is the same thing as 2 times 235. 235 is divisible by 5, which is 5. 4 times 5 is equal to 20. 35. 7 times 5 is equal to 35. So that's 5 times 47. And 47, I suppose, is not divisible by anything, really. You can test whether a number is, let's see, if I go to test prime or composite numbers. Okay, so for example, if you want to know if a number is a prime number or not, you can go to this website and you can enter your number here. For example, 47 is prime or composite. So you have it is a prime number. What I wanted to do is 2 times. This is actually not a very helpful website, actually. There was a prime composite, for example, calculator later online, for example, something like that. There is something else called the sieve of Eratosthenes or something like that, that tells you about whether number is prime or composite. Online candidate numbers prime factorization, enter an integer number, 47 for example. New is the integer 47 is a prime number. There now is a prime number. It cannot be prime factorized into other. So 47 is a prime number, but there is another website. Let me show you the website here. Calculators, numbers. Open all in new, open all, and then this website over here I've always found very helpful. primes.utm.edu. If you enter your numbers here, it tells you that 47 is a proven prime. Okay, and this is the website address. So you can use this if you need to check your numbers. So basically, long story short, then you know that 47 is a prime number, so you cannot further factorize it. So you can write 470 as 2 times 5, 2 times 7. Okay. Now what you can do is that the LCM of basically 220 and 330 and 470 is a number that contains all of these numbers, but not unnecessary factors in it. Meaning that, for example, for 220, I need 2 factors of 2, so I add 2 factors of 2. I need 1 factor of 1, so I add 1 factor of 1, or multiply basically. I need 1 factor of 11, so I need 1 factor of 11. Now for 330, I need 1 factor of 2, 1 factor of 5. So it's already here, it's already here. 1 factor of 3, so I add it here. And 1 factor of 11, which is already there. And for 470, that is 47. Suppose this is 47. For 470, this is 47. For 407, you need a factor of 2 and a factor of 5 and a factor of 47. So I need to add my factor of 47. And if I multiply all of these numbers together, I will get the LCM of these numbers, which would be basically for example, 4 times 5 is equal to 20. 20 times 11 is 220. Times, for example, 3 times 47 is 31,020, right? Is 31,020. So I write this basically this fraction. I can write it 1 over c of t is equal to basically all of these numbers, 2 raised to the power 2 into 5 into 11 into 3 into 47, and then you can divide here. So over here you see 2, you have to divide all of these numbers, the product of these numbers, by 220. So 220 has a 2 raised to the power 2 in it, a 5 in it, and an 11 in it. So these will be cancelled out. So then you would have only 3 times 47. 3 times 47 plus 330 has a factor of 2 in it, has a factor of 2 in it, and a factor of 5 in it, a factor of 3, and a factor of 11. So you would have basically one of these factors would be cancelled out. So you would have a 2, a 5, 3, and 11. So 5, 3, and 11 will be cancelled out. You will have 47 here. And over here you have the 470. The 470 is has a factor of 2 in it, and a factor of 5 in it, and a factor of 47. So you have 3 times 11 times 2. 3 times 2 times 11. So now if you add and multiply all of these numbers together, you will get your number, which is 1 over C of t is equal to, for example, your number over here, whatever that is. 3 times 47 is, now I use my calculator, 3 times 47 is 141, is 141 plus 200, 2 times 47 is 94, it is 94, and 6 times 11 is equal to 66. Adding these numbers together, you will get 141, 94, 66, 66. You will have 5 plus 6 is equal to 11, 1. 10 plus 10 is equal to 22. That's 301. That's 301. So I have 141 plus 94 plus 66 is 301. Over basically all of these numbers basically in the denominator here. So that's equal to 301 divided by all of these numbers, which is 2 raised to the power 2 times 5 times 11 times 3 times 47. Now, in order to see whether 301 could be a prime number, it could be a prime number. So I enter the number over here is 7 times 43. It is 7 times 43. So instead of this, I can write 7 times 43. So of course you can see that you cannot simplify it with your denominator. There is no common, there is nothing common here. So then you can just simply write this as 1 over C of t. And so C of t would be the reciprocal of this, which means that you have basically 4 times 5 times 11 times 3 times 47 over 7 times 43. Over 7 times 43, and that is basically your capacitance here. Now if you were to calculate this, of course this would be something like 220 times 3 is equal to 660 times 47 over 7 times 43, which is equal to something like 660 times 47 divided by 7 times 43 is equal to something about 103.06, about 103.0406, and the unit is in, I suppose, in microfarad, because everything was in microfarad to begin with. So is in microfarad. Okay, now let me check the answer over here. The answer is exactly right. Of course, you don't want to, basically, when you're doing something in electronics, you cannot do this all the time by hand, or even by a calculator. It would take a long time. So what you do is that there is websites like, for example, there is view all calculators. If you go to allaboutcircuits.com, then you see over here it says parallel resistance calculator, or basically resistor color code calculator chart, and so on and so forth, capacitance, reactance, and admittance calculator. I think this must be it. So, for example, this is for reactance and admittance. So over here you have No, not here. For example, you could go to find some website. There is a whole bunch of these websites on the internet these days. So for example, you can go for parallel capacitor calculator. Okay, and then conversion calculator, series and parallel circuits, and for example something like this. So for example, if your capacitors are in parallel, you can enter your capacitors in the same unit, which was basically, for example, 220 there, and C2 again in microfarad was 330, and you can add more capacitors in microfarad again, 470, and then the total capacitance, let me see if that changes. Yes. So the total parallel capacitance would be 0.00102 farads. Okay, and if you want to get in microfarads, it would be in parallel, right? $220 microfarad. Oh, I'm sorry, they were actually in series. I made a mistake here. I was thinking about resistors. I'm sorry. So it was 220 in microfarads. Then you have 330 in microfarads, and then you have, for example, 470 in microfarads, and you see you get over here this value in farads, which would be in microfarads would be 103.05647, and so on and so forth in microfarads, which is the value that we calculated. So that's basically, for example, one way that you can calculate these. Of course, once you know the theory, then you don't have to do it all the time by yourself. Or let's do another example here and wrap up this video. Suppose that you have, for example, 3 capacitors in series. For example, C1 is equal to 0.33 microfarad. C2 is basically 0.47 in microfarad, and C3 is 0.68 in microfarad, and you want to calculate the total capacitance here. So again, you can write 1 over C of t. 1 over C of t is equal to 1 over C1 plus 1 over C2 plus 1 over C3. So 1 over C of t is equal to 1 over, basically 1 over 0.33 plus 1 over 0.47 plus 1 over 0.68, which you can write as basically 100 over 33. Multiply both the numerator and denominator by a factor of 100 to get rid of the decimal point here, and 100 over 47 plus 100 over 68. And then if you take the LCM of these numbers, you will get something like, I will do it using a calculator, 100 over 33 plus 100 over 47 plus 100 over basically 68 is something about 6.63. Is something about 6.63 microfarad. Of course, this is 1 over C of t, and and the number, of course, it's rounded. It's a rounded number, so 1 over C of t is approximately equal to 6.63. So then C of t is going to be approximately 1 over 6.63 microfarad, which is, if I take the reciprocal of this number, it's something about 0.16151, about 0.15151. It's approximately equal to 0.151 microfarad, which is exactly the capacitance here, and we can check that here as well. For example, enter your capacitor as 0. There is no. Okay, so you see there is no point where it works. So 33 in microfarads, and then 0.47 in microfarads, and then 0.68 in microfarads. That gives you 0.150 or 0.151 in microfarads, which is exactly what we got over here. So that's basically that. So that's all about capacitors. Now we have a couple of questions here which are extremely important. You do need to go through these questions and actually do them and actually solve the problems. Otherwise, there is a lot of gaps. I mean, there is a lot of learning gaps always. Whenever you learn something new, there is a lot of learning gaps in your mind that you have to fill with the end of the chapter, exercises. That's always very, very important. So in the next video we will talk about those questions as well. I'll see you in the next video.